Hello, everyone, and welcome to a new episode of Cool Talks by Clearpix. My name is Valerio. I'm a solution architect at Clearpix, and today we are picking up from our latest episode where we introduced a brand new series on DevOps. We talked about what DevOps is in that episode, why it is useful, how it can be applied across different phases of a data, machine learning, or AI project. But today we're going one step further, and we're going to dive into how we can actually implement the DevOps practices in Databricks. And this is the agenda. Let's take a quick look. We're going to start with a short introduction where we'll refresh some of the key concepts that we covered in the previous episode. Then we'll dive into how DevOps practices can actually be applied in Databricks for data, machine learning, and AI use cases. So we're going to explore tools and features that Databricks offers to support DataOps, MLOps, and LLMOps processes. Finally, we'll wrap up with a few conclusions and key takeaways that hopefully are going to be useful for all of you. So, as we mentioned, today's session is part of a broader series in which we're going to explore DevOps option, and it's focused on Databricks. In the next episodes, we're going to look also at Snowflake and Microsoft, but let's dive into Databricks now. And as we said, a little bit of a refresher. What is DevOps? At a high level, it's a set of practices and principles that cover the full life cycle of an application. So from development to operations. It includes things such as infrastructure, provisioning, security, monitoring, and much more. Now, there are several reasons why this is important. And again, we have discussed them, but just to repeat them quickly, automation, obviously, of deployments is one of the most important ones. Reusability of all the artifacts that we develop, consistency across environments, and in general, creating a solid foundation for CI/CD, for continuous improvement and deployment processes. So how do we do this in Databricks? Let's go to the core topic for today. Simply put, Databricks is both a data platform and a software platform, right? You can have data, you store it in tables and schemas. You also can handle, let's say, other sort of files in volumes, but at the same time, you can write codes in notebooks where you ingest, transform, and model the data. And obviously, nowadays, with all the ML and AI features, you can also do much more than that, right? So you can develop ML models, you can have Gen AI application, you can build your LLM agents, so on and so forth. So all of this, obviously, is covered by DevOps in different ways. Namely, we have DataOps, MLOps, and LLMOps, as we know. And you can see on the screen which features and which, let's say, aspects of these three domains are typically covered when we talk about DevOps. And we're going to see now how each of them is, let's say, covered by Databricks. Some of them are, let's say, very coupled to their own area. For instance, you have prompt engineering and agent testing that is proper to LLMOps. Other topics are more broad. For instance, infrastructure is applied pretty much everywhere. You're always going to need schemas and tables regardless of what you do. So in general, we will see that many of the data ops concepts are always going to be involved. And if you think about it, it actually makes a lot of sense, both conceptually and in practice, because data foundation is always going to be the most important layer in your data platform before you even go to the ML applications and AI applications. And therefore, it's just natural that this also extends to DevOps practices as well. So DataOps will always be part of the DevOps process that you apply. Let's dive into DataOps now and let's see these core elements. So first of all, in Databricks, but pretty much anywhere else, the most fundamental layer is infrastructure. And when infrastructure is code, you can have repeatable, consistent, and quickly to deploy environments, let's say. It shouldn't surprise you that in Databricks, one of the most, let's say, standardized ways to do infrastructure as code is through Terraform, okay? Obviously, applicable to both to Azure, AWS, and Google Cloud as well. How do we actually use Terraform in Databricks? Well, we rely on Terraform modules, okay? We can organize them into reusable libraries. we can cover a wide range of infrastructure components, of course, depending on a specific cloud provider. And then we can combine them in composable stacks or purpose-built packaging so that we ensure that everything is parameterized, everything is consistent, and especially it's reusable and can be deployed across multiple environments. So next to infrastructure, we have other key building blocks like the ones that you see on the screen. And for them, we rely on a combination of tools and best practices in Databricks. First of all, obviously, I would say we have Git. Git is a core component in Databricks. Databricks is built on notebooks, and all of them can be version controlled using Git repositories. So you can have your GitHub or any other sort of Git repositories that you already use in your own, let's say, team, and you can connect it to Databricks notebooks. Okay, this is fully supported. It's actually strongly encouraged, and of course, you can have your branches and your different environments as well. Environments, obviously, is also a core component. We want to have environment isolation. We can do it through different branches, as we said, but also through different workspaces. Databricks is built on workspaces and different schemas. So, for instance, you could have your dev, UAT, and prod schemas, collections of databases and tables, and they could be split across different environments, even though each of them is actually still belonging to the same broader catalog. So via permissions and via proper, let's say, split of access to the specific workspaces, you can actually have a nice setup of isolated environments. We can also organize projects, okay, for teams, for example. So you can have multiple repositories. Okay, again, using your Git repositories in which you can allow different teams to work at the same time and you remove conflicts and unwanted dependencies. Next, we have a very specific and native feature of Databricks, which is called declarative pipelines. It's a fundamental component nowadays. It is growing a lot, and it's pretty much used in every production, let's say, deployment. They are essentially a native solution that Databricks offers for jobs and job orchestration and in general ETL. So you can schedule jobs and orchestrate them with this framework of declarative pipelines, and they come with built-in features such as logging, auditing, and data quality expectations. As I said, today they are really the go-to approach for most developments, and there should be a very strong reason not to use them. On top of them, they can also be integrated, okay, with other, let's say, tools and in general practices such as automated tests. For instance, we can leverage the PyTest library directly in the pipeline. Expectations, Databricks expectations are also very useful for automated tests, and they can natively be integrated into the pipelines. We can use parameterization. So when we do different deployments across environments, we can make sure that every notebook is actually looking at the right schemas, at the right tables with the right parameters. And this is all, let's say, natively available as a feature. And finally, we can also use declarative automation bundles. Nowadays, just like declarative pipelines are becoming the go-to standard, declarative automation bundles are also becoming a standard in Databricks, and they somehow replace the classic CI/CD with Git. They are a way in which you can actually deploy declarative pipelines in a very governed and, let's say, DevOps compliant way. So they're really something to look for. Finally, let's just look a bit of an example on how DataOps can be applied in Databricks. On the screen, you can see a typical setup. This is actually taken from a Databricks documentation. So we can see that we have multiple workspaces, as we said, each of them with a catalog. They are all version controlled, so you can sync your changes. You can do feature branches, environment branches, so on and so forth. So all of the standard best practices of DataOps can actually be applied in Databricks, and there shouldn't be any surprise in this sense. Let's take a look at how some of these features also look like in the Databricks application. For instance, right now we are in one of our instances of Databricks, and as you can see, we could potentially look for different workspaces. So playing with the permissions and the access of the members of your team, you can make sure that each of them only has access to a specific workspace. And also, we can work with repositories. So for instance, if today I wanted to connect to a GitHub repository, I could do it like this. So as you see, it's very intuitive. It's very well integrated. It's natively integrated. And you can connect your project from one of these Git providers easily, and then just develop code in a controlled way in your Databricks application. Next, we can move to MLOps. MLOps comes with its own set of specific requirements. As you can see on the right, we have features engineering, we have automated training, we need to deploy model, we need to validate and observe model behavior. So this comes with its own requirements. However, there's one key point to keep in mind. As we also mentioned earlier, everything starts with data. So DataOps still applies, and it directly impacts the success of your ML project in Databricks. Obviously, that's not the only thing that we need to look at, right? I mean, data scientists have their own need when it comes to ML applications. So Databricks offers multiple solutions in this sense. Some of them are based on popular libraries. Others are, let's say, managed features that have a nice UI, but after all, they really wrap what are the typical components such as MLflow and so on. Before we look at those, however, one final remark. So MLOps, as we will see later, also LLMOps actually, mainly focuses on the life cycle of the application development within one environment. So when it comes to promoting changes across environments, for example, deploying from dev to UAT, from UAT to prod, you still need to apply the CI/CD principles and all the evaluation gates that you will normally apply. Now, looking at the features that Databricks offers for MLOps, as I said, MLflow is probably the most important of them. It is natively integrated. You can use it via code and also via UI. There are features and modules in Databricks that allow you to do that, and use it for a variety of things. Experiment tracking, model evaluation, model registry, model deployments, and everything related to model lifecycle in general. You also have the feature store, which is the Databricks, a centralized repo of features to govern and reuse the available features that you have in your dataset. You have Unity Catalog, which is a cornerstone of Databricks. This natively integrates with model registry, so you can actually have models in the Unity Catalog, and therefore you can share them, you can govern them, you can manage permissions, and so on, all within the Unity Catalog next to the schemas and tables of your datasets. And then you have other more advanced features that were specifically developed for these purposes, like Mosaic AI and model serving. This is an interface that Databricks has, so a proper UI page in which you can interact with MLflow and manage the model lifecycle. You can look at the training, you can look at the deployments, you can look at monitoring endpoints for the specific models. And connected to that, you have MLOps stacks, which are a bit of the version of that we had before with the automated bundles, but dedicated to ML applications. So it's an official GitHub repo with templates that follow MLOps best practices. This is available online. It's public, so you can use them depending on your needs, and they are actually it's very encouraged to make use of them. And just like before, this is just an example of what the life cycle of an ML application can be in Databricks. As I mentioned, for instance, you can have a Databricks feature store where you can take a look at all the features available in your data set. Then you can think about model training. You can track the model behavior. You can register your model. You can serve it with endpoints. And finally, you can also monitoring and observe the behavior of the model, all within this native UI or via code if you also prefer that. So both options are available. So last but not least, LLMOps. So I'm sure most of you are familiar with the terms you see on the screen. We have prompts, we have agents, we have context, we have evaluations. So these are all elements and terms that we've all been working with that we have heard in the last couple of years. And obviously LLMOps comes therefore with its own set of requirements. However, once again, data comes first. There's no LLM app that can be successful without good data behind it. And just like for MLOps, Even in this case, we are talking about the life cycle of the app in a single environment. All the principles for promoting artifacts between environments such as dev to UAT and UAT to prod still follow, still apply, and still should be factored in when it comes to LLM applications. But now let's look at what features of Databricks allow us to work with LLM and apply LLMOps. Agentbricks is without a doubt the most important feature related to GenAI and LLM in Databricks. And I should say it's not a feature, but it's a suite of available features that Databricks offers. They are continuously developed and deployed by Databricks, and they are following continuously the evolution of the GenAI and LLM topics. It comes with a large list of capabilities. Okay, it's still built mostly on MLflow, so you can trace, experiment, evaluate, register the models. However, it has a large amount of purpose-built, user-friendly interfaces, so you can easily govern, use, keep track of your models and agents. If we take a look at them, we are talking about Playground, okay, which is a nice area in which you can prototype your apps and agents. You can test different models and prompts. You have the agents page itself, which you can build and govern the actual agents. So you can build them on your assets. You can manage the context, the endpoints, the permissions, the special instructions, so on and so forth. You have an AI gateway page, which is a central governance layer for agents. It's essentially what Unity Catalog is for data, but for AI models, endpoints, MCP servers, coding agents, so on and so forth. You can, for example, use it to analyze the usage, to configure the permissions. You can enforce guardrails, and it works for all the elements of your LLMs and MCPs. Then you have the experiments, in which you can do experiment tracking. You can check logging. You can do evaluation. You can do LLM judging. You can also do prompt and agent versioning. So all of the life cycle of the experiments happens there. You have the Databricks features, which we mentioned earlier. And then you have the models and serving pages in which you can list, share, serve your models, look at the endpoints, enable more endpoints, so on and so forth. So let's take a look at some of these features, and let's go back to our Databricks systems. As you can see here on the left, we have all of them just under the AI/ML section, which corresponds to Agentbricks. As you can see on the screen, we already have Playground open. In Playground, we can try different models. We can try different tools that we might have developed. For example, Unity Catalog functions, Genie spaces, MCP servers, so on and so forth. So it's a sandbox, essentially, where all of the elements of your application can be tested. Once we are happy with them, we can potentially deploy an agent. And here in the agents page is where you will see the agents appearing. Clicking on them, then we'll be able to, for example, add permissions, govern them, edit them, so on and so forth. And if we have, we can also look at MCP servers. So they would also be part of the list of elements here. Then we have the AI gateway, as we discussed. So in the AI gateway, we can take a look at all of the, again, agents, models, and servers, and enforce guardrails. Again, configure permissions if we need, and in general, govern all of the artifacts that we have created. Then we have the experiment page. As we mentioned, this is where we go and track the result of an experiment. Maybe we look at the logging of a model. Maybe we look at some prompts and agent versioning. For instance, if we click on one of them, we can see all of these features on the left. So, we can go and trace what has happened within a certain experiment. We can take a look at the existing sessions, judges, if we had some, evaluation runs, again, if we ever run them, and then prompts and agent versioning. All of this can happen here. Again, all has a nice UI, even though it's wrapping, popular libraries that govern the lifecycle of these elements. Databricks features is also something that we have mentioned. You can see on the screen, it's very simply a list, a place, let's say, in which we can look at the features that we have in our Unity catalog across our multiple data sets. So we can click on them and easily, go to the table or in general asset that contains them. And then we have the available models. Again, public models, private models, whatever we have, it will show here. And we have finally the place in which we can go over the endpoints in which these models are served. Again, they can be commercial models, public models, maybe stuff that we have developed. Everything will be here. Everything is governed. Everything is centralized, and everything is clickable. So, you can easily apply the changes that you need. Okay, so that was it. We've covered the 3 pillars, let's say, of DevOps within Databricks. Remember, DevOps is not just for software. We apply to data and our applications as well when it comes to machine learning and LLM. DataOps is always going to be the foundation. Okay, a reliable platform is always going to be required. So you're going to want reliable infrastructure that can be deployed across multiple environments, and you always want good data that can be fed to your ML and AI use cases. None of them is going to be successful if your data is not in good shape before. MLOps industrializes machine learning, so it offers reproducibility of the models, the deployment, and the monitoring. And then LLMOps introduces somehow new challenges. You have human interactions, so you want to look at evaluation, you want to look at safety, you want to look at the boundaries of the model, but we've seen that Databricks offers a way to cover all of that. So if I were to choose 3 takeaways, they will be the ones that I see here. If I had to start the Databricks project today, I will always look at infrastructure as code as one of the elements that I would like to apply to deploy my platform. I will use declarative pipelines and asset bundles as much as I can in order to make sure that my jobs are orchestrated and governed in the right way. And I will use agent breaks to make sure that everything I do related to MLOps and LLMOps is done in the right way, and that my application are following the best practices and standards that can be followed today. That was it. Don't forget to subscribe if you like the session. Hopefully you did. And if you have any comments or questions, feel free to drop them, and hopefully we're going to be able to answer them and come back to you. So thanks a lot for joining the webinar, and see you next time.